This is Engineered Wetlands by Mitchell, Alanna, and Aaron for Annalise. The first subsurface flow constructed wetlands originated in Europe, but have gained worldwide popularity in recent years due to their low cost to maintain, aesthetic values, and sustainability. However, there is still room for improvement. A conventional stormwater pond or detention pond, shown above, allows solids to settle, but lacks the natural structure that makes engineered wetlands so valuable. Naturalized constructed wetlands not only remove heavy metals and nutrients, but also provide habitat for wildlife and increase property values. Engineered wetlands shown below are a better option than conventional stormwater ponds, as they are a more natural area that requires less maintenance that has been proven to work for thousands of years in nature. Conventional stormwater ponds pose problems with water contamination from fecal coliform bacteria, which can be spread by geese and pet waste. This bacteria lowers the amount of dissolved oxygen, harming aquatic life. Geese like conventional ponds because the grass is kept short, leaving no place for potential predators to hide.
Engineered wetlands are man-made treatment systems that are designed to utilize natural functions of wetland ecology. There are many types of wetlands for agricultural and industrial applications. These wetlands are constructed with the objective of mimicking their natural counterparts. While land-intensive, wetlands are often a cost-effective choice of wastewater management due to the many benefits they provide the community.
Using diverse topography allows for a large variety of plant species. A more diverse plant community will attract and encourage a wide range of pollinators and wildlife. Irregular shorelines, varying water depths, and partially submerged islands comprising littoral areas should cover 20% of the wetland space. This area is characterized by emergent macrophytes like cattail and provide nesting sites and cover for waterfowl. The perimeter should be built with variable slopes rising out of the riparian zones, or the area between a land and a body of water. In doing this, you will have better control of soil erosion. Plantings here should include species which can tolerate wet root zones, like willow and red osier dogwood. This diagram shows how an engineered wetland mimics natural wetlands. This provides an ideal habitat for both plants and animals in the hopes that they will continue to naturalize and develop the area.
This image illustrates the sources of urban water pollution. Without treatment, motor oil from vehicles, pesticides, and herbicides used in lawn care can travel directly into lakes, rivers, and oceans. A constructed wetland has the ability to buffer waste before it reaches the main bodies of water. It's important for municipalities to improve water quality before it's used as a potable water source downstream. Things that get washed down storm drains should not go unfiltered into rivers and streams. Running stormwater can pick up dirt, oils, bacteria, and chemicals before it flows back into waterways. Stormwater ponds improve the water quality by allowing solids to settle. Furthermore, the vegetation is able to take up excess nitrogen and phosphorus.
Besides being used for stormwater collection and treatment, engineered wetlands have many other applications. Just as they are used to treat stormwater, they can also be used as a means of collecting and treating runoff from domestic, agricultural, and industrial sites. They can be used as an alternative to a tailings pond because they not only hold contaminated water, but they also work to clean it. Wetlands could be implemented on dairy farms and coal mines alike. Furthermore, constructed wetlands tend to house a variety of different plants and animals because they mimic the design of natural wetlands. Like the wetlands we have right here on the Olds College campus, some wetlands are set up as a place for research and recreation to take place. There is always more to learn and understand about the best ways of designing, building, and maintaining engineered wetlands. This is why research wetlands are so valuable. While a wetland may be built for the sole purpose of stormwater collection and treatment, they almost always provide other benefits like a habitat and recreational spaces. This is what makes engineered wetlands such a valuable addition to any neighborhood or community. In areas such as Fish Creek Provincial Park, an engineered wetland provides a biodiverse, natural habitat for insects, birds, amphibians, and some mammals. The natural life processes of these animals help improve the quality of the water that is filtered through this wetland. Many constructed wetlands are operated as if they are wildlife refuges, with this kept in mind.
Aside from the ecological and hydrological benefits associated with constructed wetlands, there are also recreational and educational advantages. Wetlands provide a natural feel in an otherwise urban setting. Unseen by the public are the water treatment properties of this area. The series of ponds trap much of the water runoff from the campus, which is monitored and used as a resource for education on wastewater management. As first-year students, we were invited into the wetlands to prepare for winter. Through this experience, we learned about the different types of plants found in the wetlands and how water levels fluctuate throughout the seasons. The Olds College constructed wetlands provides a peaceful and relaxing environment for students and members of the community to enjoy. The diverse plant and animal community invites visitors from spring through fall to experience this unique space.
There are many ways that engineered wetlands can be applied to a landscape. They could be used for groundwater recharge, which is when a wetland adds to the groundwater system. The exact opposite occurs for groundwater discharge, which is when a wetland takes water from the groundwater system. Sediment stabilization prevents erosion using roots tightly anchored into shorelines and riparian zones of rivers and streams. Toxin retention is achieved when contaminated water flows through the wetlands and particles in the water settle down into the wetland bed. Cattails, sedges, and other aquatic plants absorb chemicals, including motor oil and yard chemicals that have been washed from the streets into the sewage, thus reducing the levels of harmful toxins that would have otherwise washed right into the river. This is important because rivers are very often used as drinking water sources. Furthermore, engineered wetlands can be applied to nurseries and businesses as a way to clean water used during production and reduce their ecological footprint. Aquatic and wildlife diversity is achieved by engineered wetlands because they provide a habitat in places where there was previously not one. By mimicking natural wetlands, they provide a plethora of spaces for flora and fauna alike to live and thrive. This biodiversity makes the ecosystem more sustainable and enticing. That leads to our next application, recreation. When there is a beautiful green space in populated areas, it draws people out of their homes to enjoy. This fosters a sense of community and a deeper respect for the land. Like the Michael O'Brien wetland that we toured as a class, wetlands can also hold historical values. This area was dedicated to his legacy of conservation, which is honored every time the wetland is visited. Since about 60% of Alberta's wetlands have been destroyed, building new ones is a way of restoring Alberta to the way we found it.
The government of Alberta has laid out a selection of wetland vegetation that is suitable for introduction to constructed wetlands in the grassland region. A few of the recommended species include broadleaf plantain, timothy, wildmint, and cattails. These are beneficial plants because they can quickly establish themselves in an area and help control erosion, provide habitat, and diversify the plant community. They're naturally adapted and equipped to grow in the wetlands and the surrounding areas.
As outlined in previous slides, engineered wetlands have many benefits, from their sustainability to the beautiful space they provide. By following nature as a model, constructed wetlands reduce the need for high maintenance because nature takes care of itself. That being said, it is important to realize there are some liability issues and safety concerns. With the water level constantly changing and inability for ice to freeze solid at times in the winter, the water can be seen as a hazard, especially for small children like Aaron. Furthermore, the main purpose of these ponds is the treatment of contaminated water, meaning water in the wetlands has the potential to be dangerous to people. This means it is important to educate the public about the dangers of these wetlands and to have proper signage around the area.
Two major provincial statutes that are relevant to Alberta wetlands are the Water Act and the Public Lands Act, but they are affected in part by a number of other regulations. The Water Act states that whether the water is on public or private land, the Crown owns that water and the right to divert and generally disturb it. Additionally, under the Public Lands Act, the Crown owns the bed and the shores of the wetland. This gives Alberta's sustainable resource development a better opportunity to protect wetlands. The City of Calgary has released statements on wetland conservation, aiming to educate citizens by encouraging practices that minimize their impact. Habits such as picking up litter, cleaning up after your dog, reducing chemical usage in yards can have a major impact on wetland conservation.
After learning all this information about wetlands, what do we find most interesting? For me, natural wetlands have always been something I was interested in, so I had no issues with learning about their counterparts, engineered wetlands. I was particularly interested in the selection of plants to be used in a wetland. Choosing the right plants for the right place is an important aspect of any job in the horticultural field.
I found an interesting article in the Red Deer Advocate about Michael O'Brien wetlands that claims Prussian carp has been detected in this waterway. These fish are an aggressive, invasive species released from backyard ponds or aquariums. The species spreads when water makes its way back to rivers and lakes. Prussian carp are a major threat to ecosystems in North America because they outcompete native fish for resources and have no natural predators in the area.
I really enjoyed exploring the wide variety of benefits that engineered wetlands provide, from habitat to water treatment. I was most interested in the community benefits, though. I firmly believe that being connected to your neighbors and the land is the key to improving the health of our world, as well as the health of the general population. If we can get more people outside appreciating the beauty of nature, more people will be concerned with conserving it, and it's going to take everyone to fix the mess we've gotten ourselves into.